All right, in this video, we're going to talk about systems of equations again, and we're going to talk specifically about what it means to have infinite solutions or no solutions and what that's going to look like as you're solving these. All right, so if I look at this first example here, I think I'm going to choose the substitution because right here I have an x that's already by itself. It's going to be real easy to add that 2y over. Okay, so what that would look like is I got x equals 2y plus 10. I'm going to take this and substitute it back in right here for this x. What that would give me is 2 times 2y plus 10 minus 4y equals 20, right? So now I'm going to distribute the 2. So then that gives me 4y plus 20 minus 4y equals 20. Now let's solve for y. I'll notice here I got 4y minus 4y, which ends up being 0. So what I get is 20 equals 20. Now, when you have this, if you notice, all right, I have no more variables left. So what is y? What is x? If while solving, either in substitution or elimination, all of your variables zero out and all you're left with are 2 digits, for in this case, I'm left with the 20 and 20. Well, does 20 equal 20? And the answer to that is, well, yes, it does. So what this is going to tell me is I have infinite solutions, okay? Let me show you why that is. That's what it'll look like algebraically. I have the same number on both sides, all right? I'm going to erase this real quick, and let me show you what happens here. If I were to solve both of these for y, right? So I'm going to take each one of these equations, solve for y real quick. So I end up getting minus 4y equals negative 2x plus 20, divided by negative 4, divided by negative 4, right? So that's a 1. And then getting y is 1/2 x, positive 1/2 x, minus 5, okay? So now let's do the same thing for the other one. So I have minus 2y equals negative x plus 10 divided by negative 2. I get a 1 right here, so I got y equals now positive 1/2 x minus 5. And what you'll notice here is that both of these equations are now the exact same thing. So what does that mean? Well, that means they're the exact same line. So I have one of those equations that sits exactly on top of the other one being the exact same line. So no matter where you are on that line, you end up getting a solution that works for both x and y, right? So another way to think about it is if I have the exact same line, I'm going to have infinite solutions. That's what it looks like graphically, or as I'm solving algebraically, I have two numbers that both equal each other. I have a true statement that would also give me infinite solutions, okay? All right, let's take a look at another one. It's going to be very similar, right? I'm going to choose elimination on this one just so we can practice using both of them. So I'm going to multiply this bottom one by negative 2. So now what we get is 2x minus 4y equals 20 on top. And on the bottom I have minus 2x plus 4y equals negative 30. All right, and then what ends up happening here is you can see I got a 0 here for the 2x minus 2x. I have a 0 for the minus 4y plus 4y. So on the left side, I have a 0. On the right side, I get a negative 10. And what we have here is an untrue statement, right? That does not work. Those are not equal numbers. So that would tell us that we are going to have no solution. So it's different from above. When we looked at infinite solutions, you're going to have a true statement. You're going to have two numbers that equal each other. And in an untrue statement, you're going to have no solution. So what that looks like graphically is this. So if I were to take the first one, let's go ahead and solve for y. So I got minus 4y equals negative 2x plus 20 divided by negative 4 to each side. I have y equals 1/2 x minus 5 for my first equation. On the second one, I have minus 2y equals negative x plus 15 divided by negative 2. That's a 1, and I have y equals 1/2 x, and in this case I have minus 15 over 2. Now, if I were to graph both of these, right, if I graph this line and this line, what we would know is that is almost the exact same line, except for I have different y-intercepts, which would tell me that they are parallel because the slopes are the exact same. So if two lines are parallel, they're never going to intersect. And that's what a system of equations is doing. It's finding the intersection of all of the systems that you've been given. So in a no solution situation, I have non-intersecting lines, and I know that because the slopes are the same if I or to graph them, and I have a situation here where I have an untrue statement. Okay, so to recap real quick, I have infinite solutions if I have a true statement at the end when all the variables zero out, and I'm going to have a line that would be the exact same. So I've got one line that lies right on top of the other one, so I have an infinite number of intersections. In an untrue statement, like we have here, that would indicate no solution because those lines never intersect, and I know they never intersect because I look at the slope, which is the same of 1/2. Okay? Hope this video helps, and we'll see you in the next one.